Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the derivation or the expression of the path of projectile. So before going to start this derivation of the equation of the path of projectile, we have to know certain terms. The terms related to this path of projectile is number one is the trajectory. Trajectory is the path traced by a projectile in the space is known as a trajectory. Here, traced by a projectile means projectile is the particle or objective in the space, but whereas the path is traced, that path is known as the trajectory. And next one is known as the velocity of projection. What is the velocity with which the projectile is moving in the space? Here, there are two types of velocity components. One horizontal velocity component, another one is vertical velocity component. Okay, we are going to study in briefly in coming slides. And third one is the angle of projection. The angle of projection is angle with a horizontal at which a projectile projected is known as the angle of projection. How can we explain all these terms? Is very simple. Here you can see it is a horizontal and vertical, axis y and axis x, and the path is projected here. This is known as the path of projectile or path of projectile. Another name, it is called as a trajectory. The angle with the horizontal at a projectile is projected, this angle is theta or alpha, is known as angle of projection. Okay, and there is a fourth term is the time of flight. The time of flight means the time taken by a projectile to reach the maximum height and to return back to the ground is known as the time of flight. Now here we can see what is the time of flight. The time taken to travel this path of trajectory by a projectile is known as the time of flight. Starting to ending, how much time it took. Okay, that time it has been taken, that time is known as the time of flight. The time with which it flies. But here the time of flight is the time, yes, the time of flight. What is the meaning? When flight starting point to reach the destination, that time is the time of flight. Here it is, the time of flight means the time at which the projectile begins to move and it reaches the maximum height and coming back to the ground. That time is known as the time which it takes to travel. Suppose OPA, this OPA, time taking path, that time is known as the time of flight. And the next time, and the next terminology, final term is the range. Range is nothing but the horizontal distance. That is the distance between the point of projection and the point where the projectile strikes the ground. The projectile is started moving and striking the ground. This horizontal distance is known as range. It is range. This point to here, horizontal distance, OPA. The time taken to travel the projectile to the path of a trajectory, OPA, is known as the time of flight, and the distance between O to A is known as the range. Okay, so the range of projectile may be horizontal or inclined. Here it is the range of projectile is horizontal because the plane is on the horizontal plane. If you consider it is on inclined plane, the range of projectile is considered as inclined. Coming to the motion of a body, we are going to calculate the equation of a trajectory. So motion of a body thrown horizontally into the air. Here we are considering the motion of thrown horizontally into the air. What will happen when certain height after reaching, if you throw, the vertical component will be downward direction, and there is no vertical direction because of due to gravity. Okay, let us explain when the object is thrown horizontally, what will happen? There are two forces will act. Okay, or when the body is thrown in the air or in the space, there are two forces will be acted on the body. First force is air resistance, another one is gravitational force, gravitational acceleration force, that is called acceleration due to gravitation. These two forces are acted on the body when the body is moving in the space or in the air. What will happen when the gravitational force is, when it reaches the maximum, or the gravitational force, the magnitude of the gravitational force is such a way that the force created by the air or air resistance force will be neglected. That means only one force will be is considered here, that is the gravitational acceleration force. Now here, when the motion of a body thrown horizontal into the air, what will happen? Here we have considered a body thrown horizontally into the air with the horizontal velocity v. It is shown in figure. Then what will happen? The body is subjected to the following two velocities. As I mentioned here, two velocities. Number one is horizontal velocity, another one is vertical velocity due to gravitational force. Now here, what is the horizontal velocity? This is the horizontal. This horizontal force, this horizontal velocity, the magnitude of the horizontal velocity remains constant throughout the path of the trajectory. Whereas the gravitational force, acceleration due to gravity or vertical, the magnitude of the vertical velocity will be increased here from coming from top to bottom. The magnitude is going to be changed. Okay, so that means here the horizontal component of velocity remains constant both magnitude and direction, whereas the vertical component of velocity is changed both magnitude and also in direction. Okay, suppose here if we consider the path of a projectile, okay, here there is a horizontal component and vertical component. If you consider particle is here, projectile, then it is Vx, and whereas here Vy. When it reaches here, Vx, but the Vy is very small, 0. When it reaches here, the point, the Vx is remains same, whereas Vy comes down. So that means here the direction of the velocity component, vertical component of the velocity is upward direction at the initial point. When it reaches the maximum height, the projectile reaches the maximum height, it becomes 0. When it comes downwards, the path is downward path, then the direction goes downwards. A vertical component of acceleration, the direction of vertical component is downwards, and finally it reaches the maximum. Now these are the, as we mentioned here, vertical velocity, it is due to gravitational acceleration, acts downwards. Now coming to solve the problem based on these concepts, here an aircraft moving horizontally at 108 kilometers per hour at an altitude of 1000 meters towards a target on the ground releases a bomb which hits it. Estimate the horizontal distance of the aircraft from the target when it released the bomb. Calculate also the direction and velocity with which the bomb hits the target. Neglects air friction. Now, what do we know and what we want? Here, what do we know here? The horizontal velocity, that is of aircraft, is 108 km per hour. That converts, if you convert into meter per second, it becomes 30 meter per second. How to convert 108 times 1 kilometer equal to 1000 meters? 1000 meters 1 hour equal to how many seconds? That is 3600 seconds. Now it is second. If you calculate and make it simplification, then it becomes as 30 meter per second. Now horizontal distance of the aircraft from the target when it is released the bomb, we have to find out what is the horizontal distance. Now First of all, here we have to consider the vertical motion of the bomb due to gravitational acceleration only. We are going to consider it. It is due to acceleration due to gravity. Next, in this case here, the initial velocity, here it is mentioned u equal to 0 and the distance covered, the horizontal distance covered, that is 1000 meters. Now, what is the time required by the bomb to reach the ground? That is the time t. Now, the aircraft, that the maximum height, that is x equal to ut plus of gt square. That is the equation. The height of the aircraft, y component, vertical component equal to ut plus of gt square. If you substitute here, what is the initial velocity u, and here, and on one more thing, what is the g, 9.8, and what is that maximum height, that is s is 1000 meters. Now from this equation, the unknown, we have the time t can be calculated. The time t equal to 14.3 seconds. Now we know the time. What about horizontal distance? The horizontal distance, that equal to x, horizontal component x equal to v naught times t, time t. Now what is the v? What is the 30 meter per second? So that is 30 meter per second times t. Time t is substitute here, 14.3. Then it becomes 429 meters. The next objective is that direction and velocity with which the bomb hits the target. The direction is that, what is the angle? The theta is the angle with which the bomb makes with vertical when hits the target. Now what is the final velocity of the bomb in the vertical direction when it hits the target? We already calculated, that is 14.3 seconds. Now the final velocity v equal to u plus gt. We use the initial velocity 0 and substitute here g is 9.8 and t is 14.3, that is 140.1 meter per second. We know what is the angle with which, that is tan theta equal to vertical component by opposite side by adjacent side, that is 30 by 140.1. Yes, velocity components, that is 0.21, that is theta equal to 12.1 degrees. That is, this theta is known as the angle of projection. The next, resultant velocity with which the bomb hits the target. What is the resultant velocity? The resultant velocity, there are two components here. One is horizontal component. The horizontal component is 140.1. Vertical component is 30 meter per second. Okay. Vertical component is, what about the resultant velocity with which the bomb hits the target? This is the resultant velocity. This resultant velocity is nothing but, what about here? That is under square root of p square plus q square, that is 140 under square root of 140.1 whole square plus 30 whole square. That's 143.3 meter per second. That is the resultant velocity. Now we are going to calculate equation of the path of a projectile. Now we are going to consider the initial velocity. We are going to throw a ball with some angle of inclination. The path is given by the path traced, the projectile, path traced by the projectile is in the shape of a parabola. Now here it is, parabola here. Now is the trace O at the path of projectile, the particle is at P, and the maximum height reached, here it is, and it is reached OPA. The shape of the curve OPA, the path of a projector is in parabola. That's why this equation is the parabolic equation. Now, the horizontal and vertical components, if you resolve it at this point A, U having certain inclination, that is the angle of projection is the alpha, and resolve this into horizontal and vertical components, then horizontal component is u cos alpha, vertical component is u sin alpha. Okay, and OA is, what about the distance between O to A, that is a range. The time taken to travel the path of trajectory, that is OPA, the time takes that to travel, to move this O to A, this OPA is, the time is known as the time of flight. Okay, now we consider the particle, path of the particle projected from point O at A at a certain angle with the horizontal, that angle of projectile is alpha, and the particle will move along a certain path. That path is the OPA path in the air, and finally will fall down at point A. Starting point is at O and fall down point, hitting point at A. Okay, that's OPA is known as the path of projectile or trajectory. That is known as the trajectory. Now here we are going to consider U is the velocity of projection, and where is alpha is the angle of projection with the horizontal. Now consider the point P as the position of a particle after t seconds, with x and y are the coordinates. This x is the coordinate, for this y is the coordinate of this particle P. Then horizontal component of velocity for this is here for u. The initial velocity is u. For that u, horizontal component is u cos alpha, and vertical component is v sin alpha, that is u sin alpha. Okay, now the vertical y equal to, as we already covered in previous session, that is ut minus ut, s equal to ut plus of at square. From that, what will happen here? What is the s vertical distance? Y equal to, what is u? U for u sin alpha, vertical component, u sin alpha times t minus of gt square. Now, whatever horizontal distance, that is x equal to horizontal component velocity times time t, then u cos alpha into t. Now from this equation, x equal to u cos alpha t, that is t equal to, from this, x by u cos alpha. Now if you substitute t equal to in the above equation y, that is u sin alpha t minus of gt square, that is u sin alpha times, what is the t, x by u cos alpha minus of g. What about the gt? What is the t for? X by u cos alpha whole square. Then what will happen for simplification? X equal to u get cancelled. X times sin alpha y cos alpha equal to tan alpha x tan alpha minus g x square by 2u square cos square alpha. It is the whole square. So x square by u square cos square alpha, that is g x square by 2 times u square cos square alpha. Okay. Now, this equation is known as, what is that equation? This equation, that is finally, what is the y equal to x tan alpha minus g x square by 2u square cos square alpha, is known as equation of a parabola or path of a projectile or equation of trajectory. Okay. The shape of the path of trajectory or the path of projectile is in parabolic shape. Okay, that's why it is also known as equation of parabola. From this equation, we can calculate. Okay, to calculate, we can calculate 3 relations. Number 1, time of flight. Number 2, horizontal range. And finally, maximum height of a projectile. These are the 3 things can be calculated by using this trajectory equation. Okay, this equation helps us to obtain the expression of a time of flight, expression of horizontal range, and expression of maximum height of a projectile. Let us see now the time of flight of a projectile on a horizontal plane, the first component. Now let us begin. This is the path of a projectile diagram. First of all, it is the time. What is the time of flight? It is the time for which the projectile has remained in the air. That means the path, the time taken from the starting to move the projectile through OPA is known as the time of flight. Y equal to u sin alpha t minus of gt square. Now, when the particle is at point A, what will happen? The vertical distance y becomes 0. Substitute this y equal to 0 in this equation. That is 0 equal to u sin alpha t minus of gt square. So, 0 equal to u times sin alpha times t minus of gt square. then it becomes u sine alpha t minus equal to of gt square. How it comes here? Let us begin. Yes, u sine alpha t minus of gt square. That u sine alpha, that t get cancelled. That is g by 2, gt by 2. From that time of flight, the time t equal to 2u times sine alpha by g. Now what is the time? Is the time of flight, where u for initial velocity and alpha is the angle of projection, where g is acceleration due to gravity. Okay, after by using this equation, we are going to apply this equation such a way that we can solve the problem by using, let us solve the problem based on this time of flight expression. A projectile is fired upwards. A projectile is fired upwards at an angle of 30 degrees with a velocity of 40 meters per second. Calculate the time taken by the projectile to reach the ground after the instant of firing. Projectile means, what do you mean? Projectile is nothing but if you are using a gun, that bullet is a projectile. Good, that is the meaning. So a projectile is fired. That means a bullet or is fired. Then what will happen is fired upwards at an angle 30 degrees with a velocity of 40 meters per second. How much time will it take to reach the ground? That's what you have to calculate. That is nothing but time of flight. What is the time of flight? T equal to 2u sine alpha times sine alpha t by z. So time taken by the projectile to reach the ground, that is t equal to 2u sine alpha by z. Now what is it? 2 times u 40 sine alpha. Here u we know. What is u here? 40 meters per second. Here u is the 40 meters per second. That is initial velocity. The angle of inclination is 30 degrees. That is alpha equal to 30 degrees. Now what is the g is 9.8. Substitute here 2 times u 40 sine alpha 30 degrees by z, that is 80 into 0.5 by 9.8, that is 4.08 seconds. It takes to reach the ground when the projectile is fired at an angle of 30 degrees with a velocity of 40 meters per second. Okay, if your projectile is fired 40 meters per second with an angle of 30 degrees, it moves. How much time it will take? At 40 meters per second, at an angle of 30 degrees, it reaches the time of 4.08 seconds takes. Time takes. So you can also make it this 30 degrees with 40 meters per second. Suppose if it is 45 degrees, I am making with 40 meters per second, how much time will it take? You can calculate. Next, the horizontal range. The second component is the horizontal range of a projectile. The horizontal range of a projectile is nothing but, what is the horizontal range? The distance between the point of projection and the point of ground, the point of falling, and the point where the projectile returns back to the earth or returns back to the ground is called horizontal range of a projectile. Now this horizontal range of a projectile, further again the horizontal component of a horizontal velocity of a projectile, that is u sine alpha. Then we know the time of flight, that is 2u sine alpha by z. Okay, this horizontal range of a projectile depends on the time of flight. Okay, that is t equal to 2u sine alpha by z. Now we know that the horizontal range, that is the horizontal distance, equal to horizontal velocity times time of flight. So what is that horizontal velocity? That is u cos alpha times time of flight to u sin alpha by z. So now here 2 times u into u square sin alpha cos alpha by z. U square 2 sin alpha cos alpha, that is sin 2 alpha by z. U square sin 2 alpha by z is the horizontal, that is called horizontal range. This is the expression for horizontal range. Now what is it u? Where u is the initial velocity, where alpha is the angle of projection, u is initial velocity of projectile, and where alpha is angle of projection. What about g? G is acceleration due to gravity, or gravitational acceleration. Okay. Now, based on this expression, derived expression, we are going to solve the problem. Okay. Now, suppose if alpha equal to 45 degrees, then what happens? Sine 2 times 45. Sine alpha, that is alpha equal to 45, that is sine 90, sine 90 equal to 1. The maximum range or maximum that equal to u square by z. Now, for a given velocity of a projectile, the range will be maximum when sine 2 alpha equal to 1 or 2 alpha equal sine 2 alpha equal to 1 or alpha equal to 45 degrees. At that time, the projectile will reach the maximum range. Further, the maximum range simple equation is that R maximum equal to u square by z, where u is the initial velocity of a projectile, where g is the acceleration due to gravity. Now let us start solving the problem based on this concept. That is R equal range, that is range R equal to u square sine 2 alpha by z. Yes, u square sine 2 alpha by z. Let us start. A ball is projected upwards with a velocity of 15 meters per second with an angle of projection that's 25 degrees with the horizontal. What is the horizontal range of the ball? Yes, very simple. Where horizontal range, that is the given data, u equal to 15 meters per second, alpha equal to 25 degrees. We know the formula, that is u square sine 2 alpha by z. Just now we derived that expression. What is the u? 15. That is 15. Substitute here, alpha equal to 25 degree. That is by u square, that is 15 square sine 2 times 25 by z, 9.81. After simplification, you will get it, that is 17.6 meters. This R is the horizontal range. Okay. So in this session, let me summarize what are the things we covered. We covered the equation of a trajectory, and from that equation of the trajectory, the three components. What is the first component? Can be derived. First component is the time of flight. Second component is range, horizontal range, and third one is the maximum height. The maximum height are going to be calculated, but here we derived expressions of time of flight and horizontal range and applied those expressions through solving the problems. Now, what are the references were followed? Here it is. These are the references were followed in the session. Okay. Thank you for the session.
Like, share and subscribe. Hit the bell icon for more updates.